Hey guys, so today we're going to learn how to find coefficient kinetic force, okay? So bear with me because it's something that a lot of people struggle with. So I hope that you guys don't find this too difficult. So in the problem, we learn a 50 kg crate is pushed across a warehouse floor with a force of 100 Newton. So right there, I'm imagining a 50K crate. And the fact that the net force was already given to us is a huge hint. Okay, so accelerating at a rate of 1.1 meters per second squared. What is the coefficient of friction between the floor and the crate? So, like we said before, let's actually know the focus object. It helps us find the fact. So the focus object is the crate. The facts that we can pull is that this crate has a mass of 50 kg. We also can say that acceleration in this point is 1 meters. I'll just write 1 for short. And I can say that Fn, or the net force, or the force applied, because this is a force being applied to push it, is 100. So force applied is similar to net force. So what are we trying to find? We're trying to find the coefficient. So I'm going to indicate that as CKF, coefficient kinetic friction. So the equation that we're going to need is CKF, coefficient of kinetic friction, equals force applied minus mass times acceleration divided by mass times gravity. Now some of you have a different version of this, whereas this is switched around and it's negative mass times acceleration plus. Either way, you're fine with that. It's not a big deal. Okay? Plus. Okay, so now you have this. This is the equation that you have. So now you have to kind of go back and see, okay, well, what facts do I have that can actually be substituted into these variables? So that's my step 0, when you figure out how to substitute those facts. So step 0, my blueprint is, I don't know what the coefficient of kinetic friction is, but, so I'm going to put a question mark there, or CKF, either one, equals. The mass is 50, so I'm going to put negative 50. And acceleration is 1, so I'm going to go ahead and put 1. Whereas it's being added by the force applied, which is 100. Okay? And I'm dividing that by mass, which is 50, times 9.8, which is gravity. So this is what you should have in this moment. Okay, a question that you might have is, why is that okay for us to flip negative ma plus f force applied? It's okay to switch it because in the end of the day, as long as these mathematical operations show that inverse, it's fine. Because even when you switch it, it's still going to be positive force applied minus ma anyway. Okay, so now that you have your step 0, you go into your steps. You go to step 1. You see your blueprint, you attack that blueprint. So step 1. Step 1 is pretty simple for me. I'm going to go ahead and multiply negative 50 with 1, which gives me negative 50 plus 100. And then I'm going to go ahead and do 50 times 9.8. When I do that, I get 490. So this is what I have now. Then I'm going to go ahead and my step 2, I'm going to go ahead and subtract negative 50 plus 100 and divide that by 640 in step 3. So step 2, it's me subtracting that, so I get positive 50 divided by 490. Okay? And another simplified form of this can be 5 divided by 49, because I take away the zeros on the ones place. It's not necessary, really. So when I do 5 divided by 49, I should get 0.1. So that means my solution, the coefficient of kinetic friction, is 0.1. 1 or 0.1. 0.1, that would be the answer.